All right. Good evening, everybody. I want to welcome us to this class, Advanced Environmental Impact Assessment. And today, this evening, we'll be looking at air pollution. Air pollution. So I hope each and every one of us see my slide. And if you have a pen and a paper, follow me carefully so you can actually understand and get everything that we're trying to do. So I have two persons online, hoping that other persons will join as the class proceeds. All right, so today's class will be focusing basically on air pollution. And there are certain questions we'll be asking ourselves for us to really understand um, this particular topic. So we'll be looking at air pollution definition. What is air pollution? What do you understand by the word air pollution? Now, how do we measure air pollution? Because before you can actually say that the air is polluted, there should be a certain amount of those air pollutants that will be present in the atmosphere to be able to say, okay, this particular area of the air is actually polluted in that particular area. They will look at those pollutants, okay? Look at those major air pollutants. We'll discuss them one after the other. And they will look at smoke. Then what are the effects of air pollution, not just to the environment, but also to human health. So we'll be discussing those the effects of air pollution, and then what can we do? What solution can we give? All right, to be able to reduce this air pollution in our environment. So basically, these five things will form today's class, and I want to believe that we are all set to go. All right. So quickly, what is air pollution? What is air pollution? Now, I have various definitions that I can give you to actually buttress what air pollution is. Now, from what you're seeing on your screen, we define air pollution as any visible or invisible particles or gas found in the air that is not part of the original normal composition. I take it again. Any visible or invisible particle or gas found in the air that is not part of the original normal composition. Basically, we know the constituent of the atmosphere. We know that nitrogen takes about 78%, and then the oxygen 21%, and other trace elements that make up the atmosphere. Now, as outside this constituent of the atmosphere, any other particle, whether it's visible to the eyes or invisible, but as long as the presence is there, you understand that particular atmosphere or that region is actually polluted. Okay, so that's the definition of air pollution. We can also define air pollution as the release of pollutants into the air, which is detrimental to human health and the planet as a whole. The unwanted release or the continuous release of pollutants into the air that is detrimental to human health and planet. So that is the definition of air pollution. Now, there's an act, they call it the Clean Air Act, which was actually enacted, authorized in US. Nigeria is also following suit and the rest of them. Now, it empowers this Clean Air Act, empowers the Environmental Protection Agency to protect public health by regulating the emissions of these harmful air pollutants. Nigeria signed a treaty sometime in 1970, okay, on this Clean Air Act. So meaning every environmental protection agency of a particular country has been given the authority, okay, or has been given the power or is a responsibility to actually protect the public health from all these emissions. And you know very well because of the main economy of Nigeria is actually in the oil and gas, which is crude oil. And we know the things that is associated with crude oil production, from its extraction to the refining and the rest of them. Now, a lot of pollutants have been released into the atmosphere. The question now is, Nigeria as a country, do we have legislations, okay, that can help protect the human lives and the environment from these incessant air pollutants? So in the course of this particular subject, not today's course now, there's a course, there's a subject to be looking at, there's a topic we'll be looking at that deals with the legislations, okay, that are available, especially in Nigeria and of course the whole world, that looks at this. So we're going to also be discussing it in the more of the classes that will be coming in. So basically, that is the definition of air pollution. Okay, any release of pollutants that is detrimental to the lives of the environment and of course the humans living in that particular place is actually air pollution. So let's proceed. Let's look at these pollutants now. Okay, how is the air being how is the air being how are they being polluted? What are the sources? Okay, where where are all these pollutants rising from? We have basically the natural and the unnatural. Okay, natural are the natural occurrences, okay, that we may not, okay, we may not be able to control. It happens naturally, like the forest fire, which we usually experience during the dry season. Okay, dust storm, we have them. In other countries, we have the hurricane or the wildfire. Okay, volcanic eruption. Now, these are different natural sources, okay, of air pollution. So once these things occur naturally, there's bound to be movement of these particles in form of smokes and gases into the atmosphere, thereby polluting the atmosphere. So these are natural occurrences. But the unnatural, we are simply referring to as the man-made. Because of industrialization, okay, and man embracing technology in this 22nd century, most of man's activity has contributed in actually releasing these pollutants into the atmosphere. And where do they come from? We have from the coal, we have from the wood, we have from our cars, okay, the sulfur oxide, the carbon monoxide, and the rest of them, from our homes, from our factories, especially the ones that use mechanical energy. We know that any equipment that runs on fuel or diesel must definitely release carbon monoxide into the atmosphere. So from the industries, okay, especially in the petroleum industries, from the mining industries, from the, there are so many. Now, those pollutants that are being produced as a result of man's activity, which happens to be a byproduct that are released into the atmosphere, they are referred to as the man-made pollutants. So two sources of air pollutants, we have the natural and then we have the man-made. Okay, so let's proceed. So how is it measured? For us to conclude that the particular air in an atmosphere, an environment is actually polluted, there's a particular reading, okay, that we're supposed to take, measurement we're supposed to take to now say, okay, it is not harmful, or it is mildly harmful, or it is severely harmful. Okay, so look at those things. For air quality index, according to research, indicates whether pollutant levels in air, okay, may have health concerns and the rest of them. Okay, now the range is usually between 0 to 500. So we believe that the index used in measuring the amount of pollutants in the atmosphere should range between 0 and 500. Okay, now once it gets to 500 and then begins to exceed the 500, it becomes a very great concern for everyone. Okay, so that's the air quality index. Okay, it ranges between 0 to 500. Please take note of that. Anything close to 500 and then shooting above 500 becomes a very big issue for each and every one of us. So let's look at it now. For the air quality from the table, if you can see clearly my screen, what you're seeing there now, if the air quality index is between 0 to 50, 0 to 50, it means the air quality is good. No health impact is expected if the quality in the air quality index is between 0 to 50. Okay. Now, if it's between 51 to 100, it is moderate. It is moderate. If it's between 51 to 100, so usually it causes sensation for some people. Okay, especially for those who are having one health issues or the other. Now, when they constantly expose themselves, okay, to such environment, they can start having a little issues and the rest of them. Now, if it ranges between 101 to 150, it is unhealthy for sensitive people. Now, these people are those who are having respiratory diseases, those suffering from asthma and the rest of them. So these people must be limited from exposing themselves in a very long time in such an area. Okay. Now, when it's between 151 to 200, it's unhealthy. By this time, we're having eye irritations, you understand, skin irritations, and the rest of them. It can also prolong for those who are having these respiratory diseases that we talked about and other ones. It can also severe their situations and the rest of them. And then very unhealthy. We need this. In fact, this is what we need to start paying attention. From 200 and above, it becomes a very serious problem. So what we're trying to achieve from this table is this: as much as possible, we have to limit our air quality to as low as 50, between 0 to 50. Okay, because that is the range where we believe that there's no health impact of such pollutants present in the atmosphere. But when it exceeds from now 50, it becomes a concern. It is still tolerable when it's between 51 and 150. Say it's tolerable. But once it exceeds above 151 and then as high as 300 or even getting to the 500, it is unacceptable. We need to stay at alert. We need to do something. Otherwise, it's going to cause a serious health challenges for people, especially for those who have some health conditions and the rest of them. So that is the index, okay, that is used to measure air quality. Like we said, be very good between 0 to 50. Anything outside 50 should call for concern. All right. Now let's look at the measured pollutants that we have. There are basically 5 major pollutants. These pollutants are not just limited to these 5 that I want to discuss, but like we have there, they are the 5 major pollutants that the world is still battling with right now. Okay. And what are they? We have the carbon monoxide. Carbon monoxide is one of them. We have the sulfur dioxide as a second major air pollutant. And then we have the nitrogen dioxide. The nitrogen dioxide becomes another. And then, of course, we have the particulate matter as number 4. Particulate matter is a 4th major pollutant that we have. And then, of course, the last one is the ground level ozone. Okay, I just want to explain all of them one after the other, just briefly, because the emphasis is not to actually discuss them in details, but why are they called major pollutants? Let's just quickly look at it. Now, carbon monoxide, like we know, according to chemistry, has told us that carbon monoxide is colorless, it is odorless, it's a tasteless gas. So even the presence of carbon monoxide in the atmosphere may not be visible to the eyes. You remember the definition of air pollution? We said any visible and invisible, okay, pollutants present in the air that is originally not a constituent of the atmosphere is referred to as air pollutants or air pollution. So imagine carbon monoxide now, you will not be able to see with your naked eyes, because why? It is colorless, it is odorless, it is tasteless gas. And this carbon monoxide is actually produced by burning gasoline. So trust, when your car is running on a fuel, okay, it's definitely going to produce the carbon monoxide. It's also produced by burning of wood. Okay, that's also, these are some of the sources where carbon monoxide are being produced from. Okay, propane, charcoal, and other fuel. So once you burn any of these things, the byproduct of that burning is actually carbon monoxide. And trust me, where they are being discharged into the atmosphere. Okay, now improperly ventilated appliances and engines, okay, especially particularly the sealed or enclosed spaces, may also allow this carbon monoxide to accumulate to a dangerous level. And when it gets to that point, trust me, what's going to happen is that it's going to be discharged into the atmosphere. So that's basically carbon monoxide and why it's a major pollutant. So it is tasteless, it is odorless, it's colorless gas, which is produced by burning of gasoline, burning of wood, burning of propane, burning of charcoal, and other fuel. So once these things are burned, carbon monoxide is produced, and then they all ascend into the atmosphere as a pollutant. So that's that for carbon monoxide. Sulfur dioxide. Now, sulfur dioxide, as you know, is a toxic gas. It is responsible for the smell of burnt matches. Okay. Now, sometimes during volcanic eruption, okay, the natural sources of air pollution, one of the things that are being released from that volcanic eruption is also sulfur oxide. This sulfur dioxide that we're talking about. Okay, is also a byproduct of copper extraction. Sulfur oxide is also a byproduct of copper extraction. So imagine those companies that make use of copper, okay, as raw materials and everything. By the time they are extracting this copper, one of the byproducts you get from that extraction is also sulfur oxide. Okay. Now, burning of fossil fuel contaminated with sulfur compounds can also produce sulfur oxide. This sulfur dioxide that we're talking about. I take it again. I said, first of all, the sulfur dioxide is a toxic gas that is responsible for the smell of burnt matches. Okay. And I said that this sulfur oxide can be released naturally by volcanic activity. So during volcanic eruption, this sulfur oxide can be released and then discharged into the atmosphere. Then it can also be produced as a byproduct of copper extraction and also burning of fossil fuels that is contaminated with sulfur compounds. So you see that when this sulfur oxide is now produced, they are being discharged into the atmosphere. I hope you are following carefully. All right, so that's that for sulfur oxide. Then next is the nitrogen dioxide. As you know, nitrogen dioxide, it's one of the several nitrogen oxides that we have, okay, that we have presently. Okay, now it's actually produced as an intermediate. It's an intermediate industrial synthesis of nitric acid. So during the synthesis of nitric acid, millions of tons of this nitrogen dioxide are being produced. Okay, and all these things are being discharged at a higher temperature. It turns reddish brown and they are being discharged into the atmosphere. Now understand something too, that this industrial synthesis of nitric acid is what helps us to produce the fertilizer. So we cannot say, okay, let's stop this industrial synthesis of nitric acid, because the farmers and the agriculturists, they need this fertilizer, okay, to help the plants and the rest of them grow. But the byproduct of this during this synthesis is that this nitrogen dioxide is being produced, and at a higher temperature it turns reddish brown and then they're being emitted into the atmosphere. So you can see that most industries are actually at the forefront of this particular production of nitrogen dioxide, which is also a major part of the pollutants in the atmosphere. Now, quickly, the particulate matter. Okay, we're talking about the sum of all solid and liquid particles suspended in air. Okay, many of which are very hazardous. Okay, so the mixture of both organic and inorganic particles that accumulate in the air, they are referred to as the particulate matter. Okay, I take it again. I said the sum of all solid and liquid particles that are suspended in the air, of which many of them are highly hazardous. They are referred to as particulate matter. In other words, the mixture of both organic and inorganic particles, okay, found which actually suspends in the air, is also referred to as particulate matter. Example, dust, I talked about, pollen, soot, smoke, and liquid droplets. Do you understand? Now, these particles that I told you, when they all mix together, okay, and they are suspended in the atmosphere, they form one of the major pollutants of air, and they are referred to as particulate matter because they are all suspended in the air. They are mixed together: dust, soot, smoke, pollen, and liquid droplets. So all of them being suspended in the atmosphere actually contributes as one of the major um, air pollutants that we have. And then of course the ground level ozone, these are colorless and they are highly irritating gas. Okay, and they are basically formed above the earth's surface. Okay, this particular ground level ozone, they are basically what's the word now? They're basically secondary pollutants because it is produced when two primary pollutants react in sunlight and stagnant air. So until that reaction takes place, it may not be formed in the atmosphere. Okay, I take it again. I said it's a colorless and highly irritating gas that is formed above the Earth's surface. And they are called secondary pollutants because it is produced when two primary pollutants react in the presence of sunlight and stagnant air. Now, these two major pollutants that react together in the presence of sunlight, the nitrogen oxide and the volatile organic compound. The nitrogen oxide and the volatile organic compound, the VOC, the nitrogen oxide. So when they react together in the presence of sunlight, it forms what we call a ground level ozone. And like I said, it's a bit above the Earth's surface. These things are formed, this reaction takes place in the atmosphere. So you see that it becomes part of the major pollutants. I hope I've been able to explain the difference so you understand it. So these are the 5 major pollutants that we have: the carbon monoxide, the sulfur dioxide, the nitrogen dioxide, the particulate matter, and of course the ground level ozone. So you can take your time out to actually research and go in details or about, read about these 5 major pollutants for a better understanding. Okay, so let's proceed. I've already explained everything about carbon monoxide. So without wasting much time, I'm going to just go through because I've explained everything. Everything I just gave you is what I've already explained. All right. So these 5 together forms what we call smog. I hope you're not confused. Atmosphere. All right. So when the 5 of them are present in the atmosphere, they form what is referred to as the smog. Okay, like I told you, I said the word smog is derived from 2 words, smoke and fog. So a combination of both of them gives us what we know as smog. Now, what is smog? Is a type of intense air pollution. Okay, just like I said. All right. So let's proceed. So smog is a combination of gases with water vapor and dust combination of words smoke and fog, just like I said. Then it forms when heat and sunlight react with gases. That's photochemical smoke. Then it occurs often with heavy traffic, high temperatures, and calm winds. Okay, that's just a little about the smoke. Okay, a combination of gases with water vapor and dust, and is a combination of smoke and fog, which forms that word smoke. And this smoke is formed when heat and sunlight react with gas. And we said this occurs when the temperature is very, very, very high. Okay. Now, normally, smoke primarily is associated with photochemical formation of ozone. We'll look at ozone, okay, in the preceding slide. Okay, we'll start looking at the effect of air pollutant. What is the effect of the air pollutant in the environment? So we'll be able to discuss that. But just understand that smoke leads to the photochemical formation of ozone, and we know the very big role that ozone actually plays in the environment. So what are the effects? What are the effects of air pollution? What are the effects of air pollution? Okay, so we'll be looking at them one after the other. The effect of air pollution. Number one that we have is greenhouse effect. Greenhouse effect is number one effect of air pollution. Greenhouse effect, and I'm sure you guys have heard about the word greenhouse effect before. Now, what is greenhouse effect? Basically, the process by which radiation from a planet's atmosphere warms the planet's surface to a temperature above what it would be without this atmosphere. There are some gases referred to as greenhouse gases. Now, once these gases, okay, these gases are also referred to as the radioactive gases. Okay, now once these greenhouse gases are discharged into the atmosphere, the radiation from the sun, okay, the radiation from the sun, because of the presence of these green gases in the atmosphere, increases the temperature. It warms the planet to a certain level that it becomes very, very disastrous for the environment. So that's what these greenhouse gases causes. It increases the temperature once the radiation from the sun is being released. So that process, okay, by which this radiation from, the planet's atmosphere, which warms the planet's surface to a temperature above what is supposed to be, is referred to as the greenhouse effect. And of course, we know the consequence of this greenhouse effect is that it leads to what we refer to as global warming. So it's heated up. The next thing is global warming. I've heard about global warming, the ongoing rise of the average temperature of the Earth's climate system. Okay, so when there's an increase in temperature of the climate system, that is global warming. And this global warming is a major aspect of climate change. Okay, so it causes the global surface temperature to rise. And once it rises, one of the effects of global warming is that it changes precipitation. The rate at which rain falls, precipitation is changed, the weather condition changes. We can no longer observe our seasons to know whether it's dry season or rainy season. All these are effects of global warming. Why? Because the air temperature has risen to a particular level where it becomes too detrimental. I'm going to run a bit faster because I have 6 minutes left before we're done. Then the next effect of air pollution is thinning of the upper ozone layer, otherwise known as ozone layer depletion. The effect of ozone layer depletion. Just like I was talking about ozone, ozone is actually a layer, okay, that shields the radioactive materials that are being released during radiation from the sun. So what it does is that the ozone traps these radioactive materials so that it doesn't get to the earth. These radioactive materials are actually very dangerous to human health. So the ozone helps to trap them, releasing just the heat to the air crust. And that importance of ozone is that it also reduces the temperature, the heat that is being emitted from the sun, so that the heat will not be too much to kill us here. and everything. Now, what happens is that by the time you now discharge these green gases into the atmosphere, these pollutants, it goes and tears the ozone. It depletes the ozone. And once the ozone is depleted, you know the effect. That direct sunlight will now get the radiation. That radiation will now get to the earth crust with those radioactive materials I told you that is very, very, very hazardous to human health and, of course, the environment. So that's another effect of ozone layer depletion. Okay, it thins or it tears off the ozone layer, causing the direct radiation from the sun containing the radioactive materials to get to the earth crust, which is actually very dangerous to human health and, of course, the environment. And then, of course, we know we talked about acid rainfall. Now, these gases, these molecules have been released into the atmosphere. They mix, okay, they're acidic in nature. They mix with precipitation, the water molecules in the atmosphere. And by the time the rain is falling back, it's not falling as ordinary rain. It's falling, the rain that now gets to the earth crust is a combination of all these gases that have reacted with the water. Okay, it now forms a form of acid rain. You can see our roofing sheet. You see that there's changed color. This is some white particles. That's an evidence of acid rain. Why? Because of these pollutants that have been released into the atmosphere. They mix with the water molecules in the atmosphere, and then it falls back as acid rain. There are a lot of consequences with acid rain. We can't talk about the Fukushima, that Japan war, that time when for years there was no rain. The day rain came out, they were all happy, came out to drink water, and they all died. Many of them died because what they were drinking was actually acid rain, which was highly dangerous, okay, to their health. So that's one of the effects of air pollution. Okay, now other indoor air pollutions as we have the efficient distillation, bacteria, molds, viruses, and the rest of them. These are other ways we get, especially for all these people that do culture in labs, incubations, keeping, and a lot of them house dusts and the rest of them. All this contributes to indoor air pollution. Okay, because of my time, let's quickly run because I want to finish this air pollution before I do. So what can we do? What can we do now to reduce this air pollution, the effect on the environment? So many scientists and so many researchers have suggested a lot of things. We're going to look at some. If it's possible in this 22nd century, ride your bike. What do you mean by riding your bike is if you don't ride your car, bikes does not emit any form of carbon monoxide or sulfur oxide. So by the time you substitute your car to bicycle, you're saving the planet Earth. I don't know how many of us will be ready to do that in this 22nd century. But that's one of the ways we can that. Tell your friends and family about pollution. Let them understand so that if they are also contributing to to pollution in the environment, this is actually dangerous to their health, and they find a way to control the release of these pollutions, maybe from their industries or from their homes and the rest of them. Then make sure people get pollution checks in their cars and their industries. So there should be a pollution check for industries, for cars, or for any other device that emits these pollutants into the atmosphere. Okay, ride the school bus. What it means is instead of parents, 100 parents or 500 parents in a particular community all owning cars and driving their children to school, imagine 500 cars riding at the same time. Imagine how much pollution they're going to contribute. But if they can encourage the students to just take one, we only know that we're dealing with just that pollution from that bus instead of different cars and the rest of them. So those are some of the things that we can do. So I really want to appreciate us for being part of this class, and hopefully by the time we meet next week, we'll be able to talk about water pollution. Thank you so much for your time, and I will see us next week. All right. So basically, I'm going to give an assignment before I leave. I'll drop my email address. My email address is checkbardypeter@gmail.com. Check as in CHECK. Check bardypeter@gmail.com. Bardy is spelled BARDI. Check CHECK Bardy BARDI. Then peter@gmail.com. Check bardypeter@gmail.com. So those major air pollutants, I want us to do a little note, a concise note about those major pollutants: the carbon monoxide, the sulfur dioxide, the nitrogen dioxide, the particulate matter, and of course the below ozone this thing that we talked about. So those are the things I want us, those 5 major things that we discussed. I want us to write a little note about them. The carbon monoxide, the sulfur dioxide, nitrogen dioxide, the particulate matter, and the ground level ozone. Write a concise note about them, and then tell us how they contribute to air pollution. Thank you very much, and I'll see us next week.